Like this is example 6C. It's an additional example for our note 6.3, day 3 on vectors. We're given vector W, which is negative 5, 2, and we're asked to find the magnitude and the direction angle for this vector. So I'm going to go ahead and sketch W as negative 5, positive 2. So I'm going to go left 5, 1, 2, 3, 4, 5. So that's negative 5 and up 2 units. And I'm going to try to sketch the vector negative 5, 2, which is a little hard to do on this tablet. Let's call this vector W. And we're supposed to find the magnitude of W and the direction angle. So the direction angle is the direction from the angle, the amount of rotation from the positive x-axis. So we're going to call this theta. Okay, so we're going to find the magnitude of W. So the magnitude of W is going to be the square root of the sum of the squares of the x and the y components. So it's going to be the square root of negative 5 squared plus 2 squared. So it's going to be the square root of 25 plus 4, which is the square root of 29. That's the magnitude of U. And now we need to find the direction angle. So if I draw in a right triangle here coming down to negative 5, so my x direction is going to be negative 5, and this 5 in this vertical part is 2. I'm going to do a little reference angle here, which I'm going to call theta prime, which is the same thing as the tangent of theta prime is going to be the same thing as tangent of theta. So in essence, the tangent of theta prime is equal to the tangent of theta, which is the angle that we want, which is going to be the opposite side, 2, over the adjacent side, which is negative 5. And then if we use our calculator, we can find that theta is equal to the inverse tangent of negative 2/5. And if you enter that in your calculator, and your calculator's in degree mode, you'll find that theta equals negative 21.8 degrees. But now we need to stop and think a little bit, because negative 21.8 degrees is somewhere over here, negative 21.8 degrees. And it's in the quadrant, it's in quadrant 4. So I'm going to write down here, that's in quadrant 4, and we really want the angle in quadrant 2. So we have to figure out how we can get from negative 21.8, which is that theta prime, to get our true angle theta. So if we want all the way from the positive x-axis to the negative x-axis, that would be 180 degrees. So our angle theta is going to be 180 degrees minus this theta prime, which would be 21.8 degrees. And if we subtract those two, we find that theta, our direction angle for this vector, is 158.2 degrees. So you need to be careful when your vector is not in the first or fourth quadrants like it was in the first two examples, that we think about the angle that our calculator gives us and adjust it accordingly.